Welcome to today's problem-solving session. We'll be tackling a problem from the 1970 Canadian Mathematical Olympiad, which asks us to find all number triples XYZ such that when any of these numbers is added to the product of the other two, the result is 2. To restate, we need to find all triples XYZ that satisfy the following equations. First equation, x plus y times z is equal to 2. Second equation, y plus x times z is equal to 2. And the last equation, z plus x times y is equal to 2. Let's start by subtracting the second equation from the first. This gives us x minus y plus y times z minus x times z equals 0. We can simplify this to 1 minus z times x minus y equals 0. So, either z equals 1 or x equals y. Now, let's consider the case where z equals 1. Since the equations are symmetric, this immediately gives us one possible solution. X, y, z equals 1, 1, 1. Next, we consider the case where x equals y. Substituting x equals y into the original equations, we get x plus x times z equals 2 and z plus x squared equals 2. From the equation z plus x squared equals 2, we solve for z and get z equals 2 minus x squared. We then substitute this into the equation x plus x times z equals 2, which simplifies to x cubed minus 3x plus 2 equals 0. This equation factors into x minus 1 squared times x plus 2 equals 0 by using synthetic division or long division. So, x can be either 1 or minus 2. We already found one possible value of x as 1, and now we also have minus 2. Given that the equations are symmetric, we get the full set of solutions. X, y, z equals 1, 1, 1, and minus 2, and minus 2. These are the only triples that satisfy the given conditions. Thank you for following along. We hope this solution process was clear and insightful. Don't forget to follow us for more problem-solving content. See you next time.